Alright class, we're finally in the last set of notes. So we've done tons of different ways of looking at data, and so the last thing that we haven't done yet is looking at a relationship between two quantitative variables. So just as every other set of notes, we're going to go through some basic terminology and examples first to understand what's going on. So before, when we did the chi-square test for independence, that's when we were looking at the relationship between two categorical variables. So you're going to kind of hear a little overlap terminology-wise from that set of notes. So we're going to first talk about what the response variable is and the explanatory variable is, even though we did already cover that in the chi-squared, the relationship between two categorical variables notes. So if you recall, the response variable, and why we list that one first, is generally your outcome of interest. Versus the explanatory variable is then thought to partially explain this response variable. Now we are going to talk about a couple of examples here in a moment, but before we dive into those examples, I want to talk about something a little important. So inside this set of notes, it will feel a little bit like you're back in algebra class, which can be good or bad, I know, depending upon your experience with algebra. But what you're going to see showing up is x and y. And so response variable is going to be our y variable, and the explanatory, so having this x in here, is going to be the x variable that we have. And we're going to start looking at some graphs, so I just want to remind you that when we're looking at a graph, x goes along the horizontal axis and y goes on that vertical axis, and we're always going to organize our data that way as well. So just a little refresher on some algebra stuff there. Now we've gone through a couple of examples before we dive in further of just understanding response and explanatory variable. So my first example, so we want to figure out what happens to a student's overall percentage in the class as they miss more classes. So my two variables in this are the percentage in the class, in the sense the number of classes that they missed, and I need to figure out which one's the response variable and which one is the explanatory variable. So my first little label. And so which one do you think is the outcome that they are interested in? The percentage in the class or the number of classes missed? Well, generally it probably makes more sense for your percentage to be kind of what you're interested in measuring, what you would like to actually know at the end. And what we think might impact that are your number of classes that you miss. Which is an idea of response and explanatory. Let's look through this for the second example as well. So we want to see how much money I can expect to make after I've been at a company for 10 years. So if I think about my two variables, I have basically how much money I make, or kind of salary there, and how many years I've been at the company. So you can see that both those are quantitative variables, and I want to see how the one impacts the other. So your response variable is the one that you're interested in measuring, and your explanatory is one that has that impact on it. So we're trying to see how our years of experience impacts our salary. So our response variable should be the salary, and what we think explains that or affects it is our number of years at the company. And this last one you might want to try on your own before you completely watch the video and make sure we're okay with defining which one is which. So feel free to pause it here if you would like. Alright, and so hopefully what we came up with on this one is that the response variable on this one would be the price of the house. That's what we're going to be interested in actually knowing. And what we think actually impacts that would be the square footage of the house. Alright, so now that hopefully we understand looking at two quantitative variables, deciding which one is the response and which one is the explanatory, let's talk about the other things we're going to do with two quantitative variables. The first thing we're going to do is what's called a scatter plot, and this is a new type of graph, so this will give us a graphical representation just so we can see the relationship. So I can see if there is a relationship between my two variables. Then we're going to look at what's called regression, which is kind of what we're spending the most time on in this set of notes, whose overall goal is to predict y for a given x. So for example, you might want to say, well, if I miss 4 classes, what can I predict my overall percentage in the class to be? And then finally, correlation we'll talk about toward the end of the set of notes. And this looks at the strength and the direction of a linear relationship. And that linear part is important. So when I use the word linear, we're talking about a straight line type relationship here. Alright, so when we're looking at a scatter plot, there's different types of questions we're going to ask because our plot's going to look different. So just when we looked at histograms, we had certain things we went through. So here's our questions we're going to ask about a scatter plot. And the first one will feel a little weird at first, but we'll demonstrate it. As I'm going to ask if my graph seems straight enough, or what I really mean by that it doesn't really seem curved. And then if so, is it a positive or negative relationship? Or basically a positive or negative slope. There are other types of relationships besides straight line relationships, but the only one we're going to cover in this set of notes are straight line relationships. Our next question is to talk about how strong the relationship is. Basically kind of looking at how obvious is the pattern that we have. When we're talking about this, we're going to be looking at kind of how close the points are together. And then finally, we're going to just see if there's anything unusual with our plot. Alright, so we're going to look at some examples sort of going through each of these questions. And I'm actually going to pull up my notes where I can go in a little bit, zoom in on these graphs a little bit better. Alright, so let's first talk about the linear pattern and direction here. So we're looking for kind of two questions at once. First of all, if it's a straight line relationship, and when I say straight line, okay, I don't see any obvious curving with it. And then the direction of whether it's a positive slope or a negative slope. So we're looking at these first two graphs. I do use the word linear there because I don't really see a curved pattern. This seems like to be a pretty straight line on here. So if I think about it, kind of put actually a line on here, that it would kind of feel like I could put a straight line pattern through my graph here. Similar thing I could do with my other graph here with that negative. Right, it's not really curved. A straight line kind of seems like a reasonable pattern. First, if I try to do the same thing over here with this third plot, would I feel comfortable in putting a straight line through here? No, right, because I would go up and then I'd want to go down. I can't do that with just one straight line. This is why this one has no linear association. Now let me kind of go ahead and say something about this one over here. There's no linear association. And if I look at this graph, is there a pattern? Yes, there is, right? I kind of see this going up, then kind of going down, almost like our normal curve that we're used to seeing, right? There's definitely a pattern. It's just not a linear pattern. There are ways of addressing this kind of relationship. They're just not things we're going to cover in our class. Now with these other two that did have the straight line relationship, our second question about that one is if it's a positive or negative relationship. So we're thinking about slope there, if you remember that from algebra class. So we have basically as one gets bigger, so does the other. So if I go up angled up, that's going to tell me that it's a positive relationship. And if as I go left to right, I'm going down, that's going to be our negative relationship, or basically negative slope. Now thinking ahead, because we are going to focus a lot on interpretation, what a positive relationship means is as x gets bigger, y also gets bigger. Versus a negative relationship means as x gets bigger, y is actually going down. So kind of as I go over here, I'm going down, down, down. So you're going to kind of see us interpret those things as well. Our next question is talking about strength of the relationship. And so if I look at this first plot, so I kind of go through my first questions, could I put a straight line through this? Definitely. And then looking at, when I'm talking about strength of the relationship, is how close these points are to that line. So if I compare this graph to the one up here, these points are closer to that line, giving me a stronger relationship than the one I have up here, because the points are further away from that line. Now over here, we're also looking at if there's a straight line. Okay, it does sort of seem not curved, if nothing else, but there's not really a pattern here. I can't really say if there's a positive or a negative relationship going on over here. There's really no pattern with my data that I see over here. Now, as I already mentioned, we are later going to be talking about correlation, which also looks at strength. And so we don't want to ever just look at a plot to determine strength. And the reasoning behind it is plots, as usual, can be somewhat subjective. So if you think about taking the same plot, right, and I zoom in on it like a microscope or something would do, the points are going to seem a lot more scattered, versus if I zoom out, the points are going to look a lot closer together. So since plots can be so subjective, we will talk about correlation, which will give us a numerical measure of strength. Alright, finally we're talking about unusual kind of features that are on here. We'll actually start with the one on the right, because that's something we're used to having seen before, is the idea of outliers. So how outliers, if I looked at the overall trend, it kind of looks like there's a positive relationship, but there's a couple of points up here and a point here that kind of just don't seem to fit the rest of that pattern. So I probably consider these and that one to be outliers. Now again, why do I identify outliers? The first reason why I do it is so I can actually go and look at the data point to make sure I didn't, mis-enter something. Like maybe this person was supposed to be only 65 inches tall and not 75 inches tall, so I might have just mis-entered my data point. The second thing, of course, I can do is make sure they're supposed to be part of my population. So if I was only looking at women, and this was the only gentleman maybe in my sample, that would give me a reason to possibly remove it. But we can't remove outliers just because we don't like them. So right, if I find out that this number was entered correctly, they are part of my population, I am going to leave them in my sample. The other type of unusual features, just to kind of mainly introduce it, is you could have the idea of subgroups, which here I have coded blue circles as being men and these red pluses as being women. And so since you're looking at height, it kind of makes sense that there's this red section down here, because women have a tendency to be shorter than men are. So you can kind of see that there's this grouping going on. And if you actually look, this plot is actually the same as this one, where I've just now color-coded based upon male or female. So there could be something else going on, is the main reason to think about that. So when we get together next time, we're not going to go ahead and dive into regression yet. We're going to start talking about just understanding what kinds of relationships to expect and what those really mean before we get more into the algebra type stuff of actually calculating slope and intercept. So hopefully this introduction to the video has made sense. I'll show you how to do a scatter plot in class, so you won't have to worry about that here yet. But hopefully it's making pretty good sense so far.